Okay, here we are, part 3 of chapter 6. I think we're going to have probably a couple more videos before we wrap this up because we have a lot of practice problems in this chapter, seeing how to work with z-scores in all kinds of different ways and how probabilities are associated to them. Next up is practice number 4. It says find the z-score such that capital Z less than little z equals 0.2483. So now here's what they're doing in number 4. How is this different? So we're working backwards. We're not given a z-score. We're given what it's equal to, right? And we're gonna have to work backwards to find what z-score would create this probability. So here's how we need to go about it. We need to recognize that that is a probability, right? The probability of this equal. Okay, once we recognize this is a probability, we're still going to use our table of z-scores, but now we got to work it backwards. So how does that work? We're going to have to search for this number, and I say in the middle of the z-table. So we're going to have to find 0.02483 somewhere in the middle, and then off of that we're going to go back and pinpoint what was the z-score that created that probability. So for one, the first question, and what will make this a lot easier, should we be looking at the positive z-scores or should we be looking at the negative z-scores? And hopefully some of you guys know we should be looking at the negative z-scores because the probability that they tell us is less than 50%. So we know that we are on the left side of 0. We're in the negative when it comes to the z-scores. Okay, so that will eliminate half of the possibilities. And then, well, there's really no strategy I can give you from there. Just start hunting in the middle of the table for that number, 0.2483. So I got to start looking for it. I didn't find it. 0.24, here's the 0.2s, 0.24. There it is. 0.2483, way down in the corner here. Okay, what z-score is that? Negative 0.68. And there you go. Z equals negative 0.68. Working backwards. Be prepared. There's going to be styles of questions that come up, obviously in this chapter, but in later chapters as well, where we're going to have to work backwards. It's going to be pretty common. We're probably going to spend half the questions are going to be in the forwards direction. Half the questions are working backwards, just where all this is going to go in the future chapters. In fact, the very next question is along the same lines. I'm just going to show you this much so far. So there's a definition there just above practice 5 in the lecture. It says the area alpha above a z-score has a special notation z sub alpha. So here the alpha is that number 0.025. So that's telling us we want the z-score with this much area above it. And now this is unusual because in our table and the way we always think of these is the probability below. But now they're saying by definition we want the z-score with this much probability above. Well, let's write that in more familiar terms. This is what they mean. We're going to work backwards, and you can see that we've got the greater than. We want the z-score that has, capital Z is greater than what, where this much is on the upper side. If I give you a drawing, that might be helpful. Where is this to give us a probability 0.025. Where is that z-score? Okay, so there's some issues here. For one, we're going to work backwards, of course, but maybe that's not so much of a big deal. It's the fact that we've got a greater than. Well, if they give us a greater than, we can switch it around to a less than if we take the complement. So instead, we're going to think, hey, and I'll just kind of pull the next one down once we subtract. I know if that's 0.025, then the rest of this must be 0.9750. And my table now is going to work. I can find the z-score with this much area to the left below it. And at this point, it's really exactly the same question as practice problem number 4. I just had a little bit of work. I had to do the complement of that number to get myself in position first. So, okay, now we've got to hunt for this number in the middle of the z-table. And the question, of course, is should we start looking at the negative z-scores or should we look at the positive z-scores? And well, it'd be nice if this was live in class and you guys could respond. This is above 50%. So we're going to look at the positive z-scores. What was that number again? 0.9750. Okay, now we just got to hunt for it. 0.9750, 0.97. There it is. Found that one pretty quick. 0.9750. What is that z-score? 1.96. There it is. Really, that's what we're looking for. Technically, in this problem, I'm going to say this as our final answer. Z sub 0.025 equals 1.96. The z-score with this much area above, if I go back, z equals 1.96 is where that happens. Okay, so that problem, and there's all this back and forth, and that's kind of what trips students up with z-scores is, am I looking to the left, to the right, greater than, less than? You know, am I doing the normal thing in the table where I'm looking up the number, or am I finding the number first and then going back? And so, you know, which direction to use? And you really gotta, you know, just take your time and, you know, be familiar with the problems and what they're asking and what they're giving you, and understand the context. That's the challenging part. You know, we can all look up a number in a table, but right, can we make sense of what's happening in any given problem? Okay, let's move to number 6, and I'm kind of showing you some of my thoughts on that already. Now we get into the word problems. We got that 6, 7, 8, and 9, all word problems, all a little bit different. So I'm going to read number 6. The value of gifts purchased follow a normal distribution. Okay, so here they're going to get into the Christmas season. And it turns out that follows a normal distribution. Most people spend about the same. And then as you go out in each direction, fewer and fewer people spend more money and more. Fewer and fewer people spend less and less. Most people are in the middle, and it's got this nice symmetric shape. Okay, so here we go. A survey by the National Retail Federation found that U.S. women spend on average $1,228 on gifts during the Christmas season. If the standard deviation is $229.44, find the proportion of U.S. women who spend over $1,000 during the Christmas season. Okay, so here's the idea. You can tell that I'm obsessed with drawing these out. So they told us the average Would they say the average is 1,228 for U.S. women? Okay. The standard deviation, find the proportion of U.S. women who spend over 1,000. So they actually pulled it back here. The proportion of U.S. women who spend more than 1,000 is the way what they said, more than 1,000. And that's clearly more than half if the average is 1,228. Okay, so here's what we're going to do. You can see my, my steps. We're going to find the z-score that goes with 1,000. So what z-score is associated with 1,000? Once we have that z-score, then we're going to find the probability with our table, but we'll be aware they're asking for the probability greater than, over. Okay, we've done these before, just not in a word problem. So let's see what happens next. If you read through the problem, right, our x is 1,000. I'm just going to show you guys all this. It's too much. I think you get it by now. We've done enough of these. The number in question is 1,000. Our average, they tell us the standard deviation. Let's compute the z-score. Boom, boom, boom. 1,000 minus 1,228, all divided by 229. Oh, they said 44 in the question, didn't they? Not 14. 44. Hopefully my answer is still correct. Let me just double check that. 1,000 minus 1,228 divided by 229.44. Yeah, that's still going to round the same way. Okay, so clearly this doesn't come out to a nice even negative 0.99. We're going to have to round it to 2 decimal places in order to use our table of z-scores. Our table of z-scores only gives 2 decimal places, so we just got to round that like so. Okay, we have found the z-score. Now let's find the probability above that. So we're going to start with this, the probability that z is greater than negative 0.99. Well, we've got to do this complement thing. Switch it to a less than. Once we have written this, then we grab our probability table, and I'll leave this off screen because we've done it enough. Hopefully you guys can follow along. Go ahead and look up negative 0.99. And did you get 0.1611 for that probability? So then we'll subtract. And we've got our answer, our final answer to this one. The proportion of U.S. women who spend over $1,000, 0.8389, almost 84%. There is the answer to number 6. Okay. We've been going for about 14 minutes. I'm going to present number 7, and I want to challenge you guys. When I end this video, go ahead and try this one out on your own. We'll do it when we start the next video. Number 7 is about the San Diego Police Department and the average length of time that they can respond to a 911 call, and they give the standard deviations. There's an interesting twist to this problem. They mention at the end if 200 calls are randomly selected. So what I want you guys to do, find the z-score that they're looking at. They ask for the probability less than, so that's the typical. Try and at least get this far. And if you can then make sense of how to answer their question regarding that 200 calls are randomly selected, then try and finish it off and get the final answer. But if you only get this far, then I think you're doing great. Okay, we're going to end this video here. We'll do it when we come back.